Aluminum oxide ceramic insulating ring, a precision machined hollow cylinder from high-purity alumina, designed to sit between a high-voltage conductor and a grounded housing. The ring is not a structural part and not a wear part. Its single job is to hold two electrical potentials apart, kilovolts on the inside, ground on the outside, without leaking current, without breaking down, and without contaminating the space around it. That is the purpose of every dimension, surface, and grain of this component. Dielectric strength above 18 kilovolts per millimeter, meaning a 1 mm wall can hold back more than 18,000 volts before breakdown. Continuous service temperature up to 1750 degrees Celsius, well beyond any polymer or mica insulator. Ultra-low outgassing that keeps it compatible with ultra-high vacuum chambers. Chemical inertness across the full pH range from 1 to 14. And machining tolerance of ±5 microns on critical diameters, so the ring seats exactly where the assembly drawing specifies. Every one of these numbers is what separates an alumina insulating ring from a generic spacer. The outer diameter and inner diameter set how the ring fits between the conductor and the housing. The height is not cosmetic, it sets the creepage distance, the length that an electrical arc would have to travel along the ring surface from the high voltage side to ground. Longer creepage means higher flashover margin. ADCERAX machines these rings with chamfered edges to prevent chipping during assembly, with controlled surface finish to keep creepage performance consistent, and impurities from 99 to 99.9% aluminum oxide, higher purity grades for the most demanding HV and vacuum applications. Picture a vacuum chamber. An X-ray tube. A particle accelerator beamline. A vacuum interrupter in a high-voltage switchgear. Inside each of them, a metal electrode carries thousands or tens of thousands of volts. That electrode has to pass through the wall of the chamber, and on the outside of the wall, everything is at ground potential. At the interface between the live conductor and the grounded shell, something has to do three jobs at once. Hold the voltage, seal the vacuum, and survive decades of thermal cycling without failing. An alumina insulating ring does all three. The high dielectric strength means a wall just millimeters thick can stand off tens of kilovolts with margin. The dense sintered microstructure releases essentially no outgassing, so the vacuum system can reach and hold ultra-high vacuum behind the ring. The thermal stability means the ring does not crack or drift when the equipment cycles from ambient to operating temperature and back, cycle after cycle, year after year. In an X-ray tube, the ring separates the cathode assembly from the grounded anode housing. In a vacuum interrupter, it holds the arc extinguishing vacuum around the switching contacts. In a particle accelerator, it sits between each acceleration electrode and the beam pipe. When a single alumina ring fails, the entire vacuum system loses pressure and the entire high-voltage circuit loses isolation, so these rings are specified, qualified, and handled with the same rigor as the electrodes they separate.